Up high, there's because it's obviously a big, large tank, and velocities drop, lower when a large vessel. You have an automatic air vent at the top, and its valve is open. And this is what, every once in a while, you can close the valve. Obviously, you have hot water here, so you can want to take it down. You can clean it out and put it back in. Sometimes these become a nuisance because they want to just dribble water out the top of them over time because the seat might get some gunk on it where it doesn't want to seat properly. So, something to look after. So, what happens on the automation system, they enable a relay. It tells the lead boiler to start. You have a master and slave boiler. They use a communication cable between the two boilers. Right now we're having some difficulties with this particular boiler, boiler 1. We're going to get it addressed, but now we're on boiler number 2. You can disable a boiler. This is the master. The reason why it's a master is because on the controller there's a dip switch that tells it it's the master, and everything beyond it has to be a slave. So this has a particular dip switch number 2 on, that has the one off. So this boiler, even though if you turn it off, it'll still run the lag boiler on its own control, because it doesn't see the communication any longer. Okay. However, being this is the lead, it looks at runtime, and it can run either or boiler to maintain runtime. But the enable signal comes from the BMS. So it gives it a dry contact closure to start them. And then what I mean by starting, it tells it, okay, you can start if the temperature is too low. And then it also, the automation sends a different voltage signal from basically from 2 to 10 volts DC to go from a set point from 120 to 140. So that set point is going to vary based on outside air temperatures. So if this is the master and it's the lead, it runs its own primary pump. Obviously the automation enables the secondary pumps as well as the boiler, so that you can maintain hot water to all your VAV boxes and your reheat coils, your basic reheat coils and your air handlers. Right now, because of the fact that we're having issues with this boiler number 1, there is an option. I'd rather you guys read the manuals on these. That's how we gain a lot of knowledge. But you can go into the menu. There's a bunch of adjustments in here you can make. You could physically turn this one off, and it would cause that one to be the lead. Okay. There's a view menu. There's a adjust menu. There's a boiler menu, and there's a monitoring menu. So the monitoring menu, you can go through and you can look at like the temperature, inlet, outlet temperatures, the history of the highest value it's been, the lowest value it's been. So in the view menu, it just tells we're at 154 degrees. Okay, 0%. Right now there's a 2 in this one, which tells that only 2 is able to run. So in the menu screen, there is an adjust. And we can turn this boiler back on once we take care of its own internal problem. If it does fail, it'll run the lag boiler via the communication.
It won't do it automatically? It won't switch over?
It will. It'll see this one's failed. If it is failed, it'll run the lag boiler. That's correct. Even if you turn this switch off, it'll run the lag boiler.
The same with the pumps or no?
The pumps are run internally from the boiler itself.
So these ones are controlled by the EMA.
That's correct.
So if one fails, within 30 seconds, the other one turns on.
I can control, like he said I can't control lead and lag with these boilers. In other words, I want to keep the runoff as close. Run this one as lead for a week, and then next week have this one switch over automatically.
Every week,
pumps.
Every week the pump switch which one is the lead and which one is the lag, so you have an equal run.
But not the boilers, right? Just the pumps.
Yeah.
The boilers have it internally, not through the EMS.
That's correct.
I can set it up though like that, or I can't?